An introduction to probability. What is probability? Well, it's the chance of an event occurring, and often shown as a fraction or a percent. There's a formula for probability, and that is the number of events that you want over the set of all events. And that is the number of A events over the number of S, which is a sample size. So let's look at a simple example. What is the probability of rolling a 4 on a single die? Well, a single die, we'll call this the probability of getting a 4. And the number of events that you want. Well, on a die, there is only one single side that has a 4 on it. And on a die, the total sample size is 6. There are 6 sides on a die. So the probability of getting a 4 is 1 over 6. We could also express that as a percent, which is 16.7%. Okay, so what is the probability of rolling a sum of 4 with 2 dice? Okay, so probability of a sum of 4. Well, let's make a little note on the side here. How do you roll a 4? How many ways are there to roll that sum of a 4? Well, you can roll a 1 and a 3. You can roll a 2 and a 2. And you can roll a 3 and a 1. And recall that rolling a 1 and a 3 and a 3 and a 1 are different. But rolling a 2 and a 2 versus a 2 and a 2 are not different because neither die is actually changed. So there are 3 ways to roll a sum of 4. And if you remember, there are 36 ways for a die to land because there are 6 times 6 ways. So we can express this as 1 over 12, or we might say that it is 8.3%. Okay. There are 3 types of probability. So type number 1. This is subjective probability. This is purely an educated estimate with no math calculations. It can come from someone who's quite educated in an area or someone not so educated in an area. But essentially, it's just a good guess. So example, there's a 95% chance that I will be sleepier after this lecture than before. And that might be true. We're not really sure if that 95% is accurate, but it's just a good guess that probably listening to a lecture and looking at a screen for a while will make you a little bit more sleepier. Number 2, empirical. I believe that's spelled with an I, actually. Empirical or experimental probability. That's a probability, and it's based on a set of number of trials. So, for example, if you were to flip a coin 10 times and you happen to get 3 tails, you could conclude that the probability of getting a tail is 30%. And experimentally, that would be true. However, we know that a coin wouldn't land on its tail 30% of the time like theoretically we wouldn't think, oh yeah, it's going to land on one side 30% of the time unless it was some kind of weighted coin or something like that. Experimental is just something that happened. It doesn't mean that is the actual probability of something happening. The last one, and this is the one we focus on in this class, is theoretical. And theoretical probability is this is what should happen. So if all factors are fair and unbiased, here's what we would expect to happen. So we would expect the coin to land on a tail 50% of the time. However, if you flip a coin 10 times, it may or may not land on a tail 30% of the time. The probability of A is n of A over n of S, which is what we calculated above. Okay, so what's key to all of this that we're studying is that in real life, the more experiments that happen, the more closely the experiment should actually get closer and closer to the theoretical probability. So to give you an example, if you happen to go out and you buy a lottery ticket and you win big on your first try, experimentally you have a high chance of winning. Theoretically, the lottery hasn't changed at all. You still may only have 1 in 1,000 or 1 in a million chance of actually getting the winning ticket. So yes, you may win in one instance, but it doesn't mean that you're always going to win now. And the reality is if you win on that first try, it is quite likely that you'll spend the next thousands of times playing the same lottery ticket and losing every time. And as a result, what will happen is your experimental probability will get closer and closer to that of what we expect, which is a theoretical probability. So what we say is as the number of trials in the experiment increases, the experimental probability becomes closer to the theoretical probability. Okay. One of the other terms for this is it's called the law of large numbers. So we count on lots of data sets, and then in reality it gets closer and closer to what we would expect after lots and lots of data sets, which is why casinos are quite happy with lots of people coming, because in the long run they know they're going to win. They figured out that theoretically they will win this. Now, experimentally, some people might show up to a casino and win on a night, and they might feel good and positive about it. But the reality is, in the long run, they expect the casinos expect the people to lose in the long run. All right, just to review Venn diagrams, a little concept from that. The complement of A, complement, which is called A primed, is the probability that A does not happen. And the formula we can use for this is the probability of A plus the probability of the complement of A, or the probability of A not happening, should always equal 1. And here 1 is representing 100%. So for example, the probability of getting a head on a coin plus the probability of not getting a head on a coin would be equal to a half plus a half, which is equal to 100%. And we won't have an argument here about whether the coin could land on its side. And that's the end of this lecture on Introduction to Probability.